So now, what is an average velocity? Average velocity is displacement over time. So let's see, what does it mean? So suppose you have a particle. So you have particle, say particle is moving along the straight line according to the equation s equals to f of t. So you basically are given s equals to f of t. This is your t, this is your s axis, and this is how the particle is moving, right? So suppose this was at time, so this is at time t equals to 0, this is time t equals to 1 hour, time t equals to 2 hours, so on and so forth, time t equals to 3 hours, so on. Now, what is the average velocity? So suppose your particle moved from point A, so the time has changed from A to A plus h. So you have the following. So if the time has changed from t equals to A to t equals to A plus h, what is your average velocity? So the average velocity is given by the displacement, which is where is the particle at time t equals to A plus h minus where the particle is t equals to A divided by the time difference between them, right? What is the time difference between them? The difference between them is h. So this represents the average velocity, all right? So you have, again, if I draw here, maybe A is here, say suppose, then A plus h, suppose A plus h is here, then your average velocity is going to be, this is your f of A, the second one is your f of A plus h, then you get f of A plus h, so displacement, which is f of A plus h minus f of A over how much time, what is the time interval between them? The time interval between them is h. So this is your average velocity. Now, next question is, what if h becomes very, very, very small, right? So if h becomes very small, that means you're letting h go to 0. Yeah. So you compute this limit, which is same as, by our definition, this is going to be derivative of A. Of course, if it exists, this limit exists, and this is what is called as the velocity at time A, or it's called the instantaneous velocity. Instantaneous means at that instant, the velocity of your particle. So the derivative gives you the velocity. All right. So now let's look at the following problem. If an arrow is shot upward on the moon with the velocity of 58 meter per second, its height in meter at t after t seconds is given by h equals to this guy. Find the velocity of the arrow at time t equals to a. So now you have basically your moon, and on your, suppose it's a hypothetical situation, you basically are shooting an arrow. So this surface is a moon surface, all right? So you're shooting an arrow up in the upward direction. Yeah, right. Doesn't look like an arrow. Let's just try to draw more reasonable version of arrow. So you're shooting an arrow. Find the velocity of arrow at t equals to a. So v of a is going to be limit as h goes to 0, h of a plus h minus h of a over h. Yeah. So this is going to be limit as h goes to 0, 58 times a plus h minus 0.83 times a plus h the whole square minus h of a, which is going to be 58a minus 0.83 a square, the whole divided by h. Now we need to find this. So how do we go about it? You have let's group these two things together. So we'll group this guy and this guy together. So you get limit as h goes to 0, 58 a plus h minus 58a. So I've grouped them together. And I'm going to group this together. So minus 0.3a plus h square minus a square, the whole divided by h. Now I can expand and simplify. So we get, this is going to be limit as h goes to 0. I get 58. So this is going to be, what do I get out of this? I get 58h from the first part, because 58a minus 58a, that will cancel. And here I'll get 0.83. Now a square minus b square is a plus b, which is a plus h minus a. Then a minus b, which is a plus h minus a, the whole divided by h. Now I need to borrow some space here. So this is going to be limit as h goes to 0. I'll get 58h minus 0.83 times this a and this a will cancel. So there's one with the plus and the one with the minus. So we get 2a plus h times h divided by h. Now there is a factor of h on the top and there's a factor of h in the bottom. You take it out, cancel it, so you get limit as h goes to 0 of 58 minus 0.83 times 2a plus h. And now you can let h go to 0, so you get 58 minus 0.83 times 2a. So this is your answer. All right. So that is the, all right. Now let's answer the next question. When will the arrow hit the moon? Okay, so you're on the surface of moon, and when you're shooting the arrow, so at that time, so what happens when does the arrow hits the moon? When you have h of t, the height is 0. So you try to simplify this now. So h of t is going to be 58t minus 0.083t square equals to 0. Take t common. You have 58 minus 0.83t equals to 0. This implies either t equals to 0 or t equals to 58 divided by 0.83. So this was at when that arrow was shot, right? So this was when arrow was shot, right? So this is not the time. So when will it hit back moon? It will hit back moon when t equals to 58 over 0.83 seconds. All right. Now the next question: with what velocity will the arrow hit the moon? So in that case, we have to find out h prime at 58.83, which is simply substituting in this equation. We are substituting instead of a, we are going to substitute what? Or rather here, instead of a, we are going to substitute this value. So we get, so this is 3 here. So we get 58 minus 0.83 times 2 times 58 divided by 0.83. Okay, so this is the velocity with which it will hit. So you can see, if you want to simplify this, you can go ahead and simplify this 83, this 83 will cancel. 58 minus 2 times 58 is going to be minus 58. And what are the units? The units are measured in meter per second. So we'll have minus 58 meter per second. The negative sign indicates that it is what? In the negative direction. So this form is a calculator ready form. So we expect in exam that you are having a calculator ready form, right? So you see that your derivative gives the velocity. Now there is another way to look at the derivative. So we have, let f be a function on an interval I and let x1, x2 belong to I. Then the increment in x, if x changes from x1 to x2, so suppose your x started with x1, then it changed to x2, then the increment in x is defined as delta x. So this is read as, this is delta. So delta x is x2 minus x1. Similarly, the change in y will be what? How did your function change? So your function value is going to be, it will change from f of x1 to f of x2, right? So we get what? We get delta y is going to be f of x2 minus f of x1. Now, therefore, the average rate of change in y with respect to x is going to be what? On x1, x2 is going to be how much did your function change or y change divided by how much did your x change. That is going to be f of x2 minus f of x1 over x2 minus x1. Now, how would we get the instantaneous rate of change? If you let limit delta x goes to 0 of delta y over delta x, you get limit as x2 goes to x1 of f of x2 minus f of x1 over x2 minus x1. Now note that you must be wondering, what should I change here? Should x2 go to x1 or x1 go to x2? So your x1 is fixed, and then from there you are measuring the change. Oh, it went to x2. So it is x2 goes to x1, and this can be written as, if in your notation, this can be also written as f prime of x1, right? Or generally, this is written as limit as delta x goes to 0, delta y over delta x is dy by dx, which is f prime of x. Yeah, so this was a notation used by Newton while trying to come up with the idea of derivative. Okay. So this is what your instantaneous rate of change is. So instantaneous rate of change is this guy. Okay. So you have seen instantaneous rate of change of y with respect to x and average rate of change of y with respect to x. Now let's use that concept and apply it on the following problem. So let's do this problem. So let's read this problem. So if a cylindrical tank holds 1,000 gallons of water, which can be drained from the bottom of the tank in an hour, then the Torricelli law gives us the volume of the water remaining in the tank after t minutes is this. Find the rate at which the water is flowing out of the tank, the instantaneous rate of change of v with respect to t. What are the units? So the problem is asking you, what is the instantaneous rate of change? So that is given by dv by dt. or you can write it as v prime of t. So that is going to be limit as h goes to 0, v of t plus h minus v of t over h. That is going to be limit as h goes to 0, 100,000, 1 minus t plus h by 60 the whole square minus 100,000 times 1 minus t by 60 square the whole divided by h. Now later on when we'll come to the formulas for computing this using derivatives, you will see that it will become easier to deal with this. But for now, we do not know any formulas of derivative because we haven't constructed any one of them. So we have to work with this. So I can simplify this by taking 100,000 out, limit as h goes to 0, 1 minus t plus h by 60 the whole square minus 1 minus t by 60 the whole square divided by h. Now you can use a square minus b square formula. So you get 100,000 limit as h goes to 0. Now a square minus b square is what? A plus b. So a is the first part. A minus b, which is a t plus h by 60 minus 1 minus t by the whole thing divided by h. Right. Now we have to simplify it. So let's simplify this. So this is going to be 100,000 times limit as h goes to 0. So this will add with this, you will get 2. And here you will get what? Minus t by this. So it will become, since the denominators are same, I can add the numerators directly. So minus 2 t minus h. Or if you want to keep the minus sign outside, we can do this. And for the remaining part, you have minus 1 will cancel. Minus t will cancel. You'll be left with minus h by 60, the whole divided by this h. So this h and this h will cancel out. So this h goes 1 time, this goes minus 1 times. And now you let h go to 0. You will see that this will become 2 minus 2t by 60 multiplied by minus 1 times 1 over 60. So 1 over 60. Yeah. So this is what you get. And of course, multiplied by this 100,000. So this is your answer. And this is a calculator ready form. So I'll leave it that. This is your v prime of t. All right. So that take cares of this discussion. Let's move ahead. Now, so recall the derivative of the function is given by f prime a equals to limit as h goes to 0 f of a plus h minus f of a over h. Now let's try to find the derivative of function f of x equals to x squared at x equals to 0. So you can see limit as h goes to 0, f of 0 plus h minus f of 0 over h. So this is going to be limit as h goes to 0, 0 square. So 0 plus h is going to be h, and h square minus 0 over h. This 1h will cancel out, so limit as h goes to 0 of h over h, which is h square over h, which is going to be, this can cancel. You will get equal to limit as h goes to 0 of h, which is going to be 0. So the derivative, so f prime 0, so this implies f prime 0 equals to 0. Now let's similarly work for x equals to 1, x equals to 2, and x equals to 10. Now why don't we work directly with x equals to a? Yeah. So what is f prime of a? F prime of a is going to be limit as h goes to 0, f of a plus h minus f of a over h. This is the definition of derivative, right? Again, limit as h goes to 0, a plus h the whole square minus a square by h. Now you can cancel the factor of h from top and bottom. So what do we get? We get a square plus 2ah minus h square, sorry, plus h square minus a square by h. So instead of using a square minus b square, this time I decided to expand a plus h the whole square. So we get limit as h goes to 0. This will cancel out with this guy. You can take h common. You will be left in bracket 2a plus h by h. This h cancels, and when h goes to 0, what do you get? 2a. So f prime a is 2a. Now note that this acts like a function. So that f prime x is like a function, right? Why is it like a function? Because f prime of x, now I can write it as, instead of a, I'll reuse 2x. That means for input x, the output is 2 times that. So we can define a derivative as a function now, because as you can see in this case, your derivative depends on input. Based on the input, the output is dependent, right? So we have the following. Let f be a function from I to R, and let this function be given to you. Then consider all the subset, so consider the set of all the points inside I at which the f prime exists. Then if j is non-empty, then this new function f prime from j to r is called the derivative of f. Now here we are insisting that the derivative should be defined at some point to talk about it as a function. That's the whole point of this definition, right? If j is empty, suppose if j was empty, that means that the derivative is not defined at any point. In that case, we do not have really the concept of function, right? The domain should be non-empty to have a function. So if I want to pictorially draw this, I have a function f. So I have a domain D, or in this case I, on which my function is defined. And so it's a function from, this is my original function f from I to R. And then my derivative should be at least defined on some non-empty set to talk about derivative as a function. Okay. Now, let's look at the following example. So consider the following function. Now, what is the domain of this function? Anyone? So domain of this function is, since you're squaring first, square of all numbers is okay, right? And then taking cube root of a number is, no matter what your number is, cube root is always well defined. So you get domain of this function is all real numbers. Now, determine the formula for the derivative of this guy. So let's work on that. So f prime x is going to be limit as h goes to 0, f of x plus h minus f of x over h. That is going to be limit as h goes to 0, x plus h to the power 2 by 3 minus x to the power 2 by 3 over h. Now you need to cancel the common factor of x plus h from top and bottom. Now if you work it out, so homework, you have to basically rationalize it, but you have to raise it to power 3. So you have x minus a, and you want to raise it to power 3. In that case, you have to multiply by x squared plus ax plus a squared. Yeah, to raise it to power 3. So you should do that. And you will see that this limit is, so you should fill in the gaps. That's the homework, is 2 by 3 x to the power 1 over 3. So in this case, what is the domain of your function? So domain of the derivative. Domain of f prime is all real numbers except what? Except 0, because at 0 it becomes, the denominator becomes 0, so it's not defined at 0. All right. Now let's draw the graph of this guy. So this is how the graph looks like. So the graph of the function is, so it's x to the power 2 by 3. And note that it is symmetric in y-axis. Why? Because it's an even function. So this is how the graph looks like. Okay. Now, what about the derivative graph, right? So derivative graph basically is, so this is your f of x graph. So this is the f of x graph. I'll draw the derivative graph on top of this here. So the derivative graph actually looks like 2 by x to the power 1/3, which almost looks like 1 over x, and you'll see that that is going to be a graph like that. Yeah. So this red graph is your derivative graph. Okay. Now, so let's see, how do we draw a graph of function? So given f, the graph of f is given. Let's sketch the graph of f prime. So this is your graph of f of x. Sketch the graph of f prime. So can you go ahead and sketch the graph of f prime? So at this point, so this is your graph of f of x. And at this point, the derivative is going to be 0 because the tangent line are horizontal. That means the slope of tangent line is 0. So let me just, so at these points, it's going to be 0. Okay. Now, before this point, the function is increasing, right? So the function is increasing, the derivative is positive. We already saw that. So before this guy, so the function is positive, the derivative is positive, but it goes all the way to become 0. So the derivative, the slope is getting smaller and smaller, this point, and then it basically goes on to become 0. After that, the function is decreasing. That means the derivative is negative, and it goes on. And then the derivative starts increasing. Later on, we'll see this important point at which the derivative starts from decreasing to increasing. We'll call it an inflection point, but that's going to come much later. However, it basically then has to become 0 again. So it will increase to become 0. And after that, the function is increasing. That means the derivative is positive. So this is how roughly p prime x looks like, f prime x, right? This is a rough sketch of f prime of x. All right. So let's move ahead. Now derivatives are given. There are many notations for derivative. So you have f prime. If y equals to f of x, then derivative can be written as dy by dx. That is same as f prime x. That is same as df by dx. That is same as d by dx of f of x. That is same as dfx. And that is same as dfx, but with respect to x. So these are all notation for the same thing. The reason for that is later on when you do multivariable calculus, you will see that these notations are useful. And this makes clear, if I write f prime, it doesn't tells me what the variable is. But if I write dy by dx or df by dx, it tells me exactly what variable is, all right, with respect to what variable am I taking derivative. So now, a function is differentiable at a if f prime a exists, right? A function is differentiable on open interval a, b, or for that matter, a to infinity, minus infinity to a, or minus infinity to infinity, if it is differentiable at every point inside the interval. Now note that this is an extension of your definition in some sense, because until now you talked about derivative at a point. Now you can say the function, so to have a derivative at a point means the function is differentiable at that point. Now you can extend that definition to the whole interval. So what does it mean by the function is differentiable at on interval AB? It means that it's differentiable at every point inside the interval. Okay. So now this is two very interesting questions to ask. The questions are, is continuous function differentiable? Is every continuous function differentiable? And the answer is no. Why is that? Let's look at the following example. We just saw this example some time ago. So let's look at f of x equals to absolute value of x. So let me draw the graph of it. The graph will look like it's a piecewise function. So this is how absolute value of x, f of x equals to absolute value of x looks like. And we have already seen that f prime 0 does not exist, but f is continuous. As you can see, f is continuous at 0, right? Now, one way to see that y f prime, geometrically, to see that y f prime 0 does not exist, because derivative is slope of the tangent line, right? The tangent line, the word important. So there should be unique tangent line, but at this point there are so many tangent lines, right? Or so many lines which touches it at this point, right? So there's no tangent line because there's so many lines, right? There's no the tangent line. So therefore, this function is not differentiable at 0. So similarly, if I ask you, give me example of a function continuous at a, but not differentiable at a, what will the example be? It will be f of x equals to absolute value of x minus a. This is continuous at a, but not differentiable at a. So f prime a does not exist. This is shifting this point here to a. Now the next question to ask is every function differentiable? Every differentiable, sorry, my bad. If every continuous function, sorry, every differentiable function continuous, right? So let's look at that. So f is differentiable at a. We are asking the question, is f continuous at a? Is f continuous? So is f, so question is f continuous at a? Now for that we need to show that is this equal to f of a? This is what we want to understand. Is it true or not? Given we are already given that f is continuous. Sorry, f is differentiable at a. And then we are asking is f continuous at a. So note the following. What is limit as x goes to a, f of x minus f of a over x minus a times x minus a. Now note that the function is differentiable. So therefore this guy exists, right? So this is going to be f prime, what? F prime a times x minus a, limit as x goes to a. So this is going to be 0. That is, limit as x goes to a of f of x minus f of a is 0. This implies limit as x goes to a of f of x is equal to f of a. Therefore, f is continuous at. Therefore, f is continuous at a. So differentiability implies continuity. Now, consider the cases where the function is not differentiable. So let's try to understand that. So what are the problems with the differentiability? So first problem is that the function may have corner, right? So f of x equals to absolute value of x. It's not differentiable here, right? Not differentiable. Why? At x equals to 0, because it has corner at that point. Okay. Now, so second is if function is not continuous at that point, right? So for example, you have a function like that, I mean, how would you draw a tangent line, right? It doesn't make sense. If you come from here or here, and in this case, it could be here or here. So we have already shown that f is differentiable implies f is continuous. So contrapositive of this statement is if f is not continuous, then f is not differentiable. Okay, so in logic, you'll see this later. If you have already done Macam, you'll see P implies Q is same as negative Q implies negative P. These two statements are equivalent. Now the third problem could arise is your function has a vertical tangent line. So what do I mean by that? Let's look at the following example again. So let's look at the function f of x equals to x to the power 1 over 3 or cube root of x. So the graph looks like it's the inverse function of cube root of x. Sorry, it's the inverse function of x cubed. So you can reflect to draw this. Either you can take y equals to x cube and reflect it in line y equals to x, because that's how we draw the inverse functions. So let's draw this guy. So this is how it looks like. Something of this sort. And as you can see here, the tangent line, if you look at the tangent line here at 0, it becomes what? Vertical. So here we get what? Vertical tangent line. 0, right? So we get a vertical tangent line here. So that's why the derivative does not exist at that point, because derivative is a slope of the, because slope of tangent line is equal to derivative, right? At point P, A is derivative at A. And in this case, the tangent line is vertical, so the slope is not defined. Therefore, the derivative is not defined. Okay. So these are the three problematic cases in which case the derivative does not exist. Now, we can also define, so if you take, let's take f of x equals to x squared. Then we get f prime x equals to 2x, right? Now think about f prime x. F prime x is also a function of x, isn't it? Yeah, we have already seen this. So we can find out f prime x prime, right? So basically, you can take derivative of a function many times, all right? So first of all, f prime prime is f double prime. So this is the second order derivative. Second order derivative. There are various notation for it. You can write y prime prime is y double prime. And then another notation is d by dx of dy by dx is d square y by dx square. So we already have seen f prime x is 2x. Now what about f prime prime x? That is going to be limit as h goes to 0, f prime of x plus h minus f prime of x over h. That is going to be limit as h goes to 0. What is f prime of x plus h? Wherever there is x, you'll put x plus h. So 2x plus h minus 2x over h. You can cancel the 2x plus 2h minus 2x over h. And that will give me limit as h goes to 0, 2h over h, which is going to be 2 after cancellation. All right, so this is what the prime prime or f double prime x is. Yeah, so f double prime x for this function is 2. And similarly, you don't need to stop here. You can see that f triple prime of x is going to be limit as h goes to 0, f double prime of x plus h minus f double prime of x over h. This is limit as h goes to 0, What is f double prime of x plus h? No matter what your input is, the output is constant. So it's going to be 2 minus 2 over h, which is 0. So later on, we'll see that derivative of constant function is 0. All right. Now let's move to the last problem. So recall, the instantaneous rate of change of displacement is velocity, and instantaneous rate of change of velocity with respect to time is acceleration. So acceleration is derivative of velocity, but velocity is derivative of velocity is derivative of displacement. So velocity derivative is second derivative of displacement. So now you are given the particle is, these are the graphs. One of this is a position of the particle, one is the velocity, and the other one is acceleration. So which one is which? Let's try to see that. So any ideas? So how do we even approach this problem? So in this case, let's see, where does this guy becomes 0? So this guy becomes 0 at this point. And it is decreasing from here to here. So that means it should be negative, and after here, it should be positive. So you see this orange line is following as a derivative of, so let me call this as h of t. And let me look at the orange line. Let me call orange line as g of t. So you can clearly see that h prime of t equals to g of t, right? Now let's look at the next one. So here we have another function. So in this case, the derivative is 0 here. And if we look at this, so derivative of the orange function should have been here. So that is not there, right? So that means the derivative of the orange function is not here at all. So the orange function should be your, the derivative of orange function is not here. So let's call this as g of t is going to be a of t. All right. Now, as you saw that h prime t is g of t, so the velocity derivative is acceleration. Therefore, we get h prime or h of t is your v of t. So h of t is your v of t. So what is h of t? So this blue one is your v of t. Right? And then you can see that this function f of t is going to be a s of t, which is the displacement. Right. So this